Hello, my name is Josiah Jones, and this is my machine learning project on the incarceration rates within Tennessee. So basically, African Americans within the United States have been disproportionately incarcerated. I can go over it in too much detail. However, you can always look it up, educate yourself, basically, so we can learn more about this issue in the United States. However, that's not what this project is about. This project is using past data of African Americans, black African Americans, who have been basically incarcerated, incarcerated within the prison system of Tennessee and its respective counties. So I grabbed this data set from the Barrett Institute of Justice, and I thanked them for that. And so I used Jupyter Notebook and Python to help write the code for this project, and I used Pandas and scikit-learn to be able to basically clean up my data and use it for models and different models and things like that. So my data preparation, it was a large data set. It had all of the counties in all of the states, including DC, United States of America, and it had over 1 million points of data. And so I first checked the memory usage of the entire project. It was huge. My computer wouldn't have been able to handle it. So what I did was I changed the bits of the floats and integers. So it was floats and integers both 64-bit. I changed the float from 64-bit to 32-bit, and integers from 64-bit to 8-bit. After that, I dropped all the object columns that were within the data set. They were unnecessary for my project, and plus the code one that ran if the objects were still there. And so after that, using the pandas drop function, I used it to get rid of all the states except Tennessee, and to get rid of all the years before 1990, because again, memory issue. My computer actually got a black screen at one point. So yeah, so that's what I did to get the data I used. So after that, I made 3 copies of the data set. That's how I can get a regular, normalized, and standardized data set. After that, I used a train test split from scikit-learn to have them each be able to use the model separately. And the target I chose when using the train test split, I chose black prison admissions. However, there are plenty of different other ones that I will eventually check out. However, for the sake of memory and time for this project, I only chose one to look at. And the results right here are, first I used something I learned in this class. Basically, it plots all the models within the graph. On the graph, it plots 10 regression models on the graph, and the x-axis has the amount of folds, which basically increases the variance between the sorry about that. It increases the variance between the data sets. That way it can have a better understanding of how actual real life data will be. And the y-axis has RMSE, which stands for root mean squared error, which basically just shows how much error the model is experiencing within the graph. As you can see, I first have the regular one. I have the normalized right here, and the standardized right here. So I want to see which model would end up working best with this data set. And so that's what I did to find out. And so you don't want a root mean squared error too high, but you don't want it to be 0 either. Because if it's 0, it means that it's overfitting, meaning that when it actually goes out to test the data, it means it's not gonna do very well with another data set. However, if it's the root mean squared is too high, that means it's underfitting, meaning it's not doing well enough to fit the data. And so here I have the regression graphs right here. So I had an error graph that basically on the x-axis had the actual value, which is where the data points were plotted, and the predicted value. And so basically the line followed the actual value and the predicted value to make a perfect line, which is what that yellow line is. And the blue dots are the data. And as you can see, the linear overfits to the extreme on both the regular and the normalized regression graph, meaning it's not something we want to use in a data set, and especially for standardized, where it wasn't, that red line you see right there is basically the error between each data point, and as you can see, it wasn't even able to do it with the standardized data set, meaning we don't want to use linear regression model. Here we have the residuals graph, which is basically the same thing, except that you're comparing it based off of two graphs instead of one this time. So one is linear regression residuals, as you can see, overfits for the regular and the normalized and the standardized regression. And for the k-nearest neighbors regression, which is basically it checks to see which ones are closer, so that way it can plot the data. I'm not going to explain it. If you want to look it up, you can look it up. But basically, this, as you can see on the k-nearest neighbor residuals, it's doing a better job. However, it does look as if there are some outliers within the data set that I might need to get rid of so that I can better accurately plot the data. As you can see, there are huge amounts of error or residuals between each one. And so using what I learned in chapter 11, I found that the best model was the lasso linear model 64, which polynomial degree of 2, meaning x squared, meaning the U shape, if you remember in algebra, or any math class really. And so the data convergence was also true. However, I was unable to use most of the methods used later in the class because there are 4 classification models, which basically groups data together based off of the data it gets, instead of predicting a number like I did with the regression model. So I was unable to use the majority of the methods. So that is why I was only able to do these 2 things for the latter half of the project. So the conclusion of future-related words, I consider this project to be a stepping stone because I really only found models that work best with the dataset. And with computer limitations, I was unable to test every model, like to see which one actually worked the best. I was unable to do that. However, I hope to go back to this project one day and really see how well this project works out. And so this very website, like I said, you can check it out right here. And in fact, I'll click on it and we can go see how well it's doing. So as you can see, it has pretrial jail incarceration rate. And if you press this button, select data, you can see jail admissions, pretrial prison incarceration. And you change it between states and counties. You see it makes it different. Oh, this probably isn't the best one to see that with. So how about jail admissions? Yep, there we go. As you can see, it is different here. And then you can also change the year with this slider right here. And we can also change it to, as you can see, the states. So let's do prison incarceration. How about jail incarceration instead? And then Black African American rates. And yeah, as you can see, it has different ones all the way up to 80. However, it does go up all the way to 90 if you press all, and then you should be able to see it all the way to 1970, as you can see. There. Anyway, that is it for my project. I hope you enjoyed the presentation, and thank you for allowing me to present.